Numerical values and mathematical operators form fundamental components of programming languages. Just like mathematics, Python utilizes numbers for computations. There are two primary numeric types in Python. Integers, these represent whole numbers, including positive, negative, and zero, such as 5, 0, -10. Floats, these represent numbers with decimal points, like 3.14, 12.3, -10.5. Python provides a robust set of operators to perform various calculations on numerical data. These operators act like tools. Let's explore the fundamental operators. Addition operator. The plus operator is utilized for adding two numbers. Subtraction operator. The minus operator subtracts one number from another. Multiplication operator. The star operator performs multiplication between two numbers. Division operator. The slash operator divides one number by another. In addition to the four basic math operations, Python has three other useful operators for working with numbers. Modulo operator. %sign for the modulo or mod operator that returns the remainder of dividing two numbers. Exponentiation operator. Double star is used to raises one number to the power of another. Floor division operator. Double slash is also used for floor division, which performs integer division, discarding any remainder. Now, let's go back to our coding environment and see how these operators work in practice. Let's consider two numbers, 5 and 2. We use the print command to see the results of applying the addition, subtraction, multiplication, and division operators to these two numbers. Next, we perform the four basic mathematical operations on the given numbers. You will observe the application of these operators to the numbers. The outcomes will be displayed on the console. 5 plus 2 equals 7. 5 minus 2 equals 3. 5 times 2 equals 10. 5 divided by 2 equals 2.5. Let's use the print command to practice with the three operators: mod, exponentiation, and floor division. After running the code, the results of these operators applied to the numbers 5 and 2 will be displayed in the console. The remainder of 5 divided by 2 is 1. 5 raised to the power of 2, or 5 squared, is 25. The result of floor division of 5 by 2 is 2. While the last three operators might seem less common, but they are still important and have many practical uses in programming. For instance, let's say we need to check if a number is even or odd. We can do this by checking the remainder when dividing the number by 2. If the remainder is 0, the number is even. Otherwise, it's odd. The mod operator makes this task easy. Here are two examples. Print 6 mod 2, which is even. Next line. Print 7 mod 2, which is odd. When we run the code, we see that the result for the number 6 is 0, which means it is even. And for the number 7, the result is 1, which means it is odd. Using the mod operator is the easiest and quickest way to check if a number is even or odd. When an expression has multiple operators, Python follows a specific order called operator precedence to calculate the result correctly. This order is also known as PEMDAS. PEMDAS is an acronym that stands for the order of operations used in mathematical expressions. Parentheses. Operations inside parentheses are performed first. Exponentiation. Raising a number to a power is evaluated next. Multiplication and division. These operations, which are of equal importance, are performed next and executed from left to right. The mod and floor division operators also follow this rule because they're considered types of division. Addition and subtraction. Lastly, these operations, which have the same weight, are executed from left to right in the order we write them. Remember, when in doubt about operator precedence, it's always a good idea to use parentheses to make the order of operations clear. This rule determines which operations to do first when evaluating an expression. It helps make sure the result is consistent and accurate. Here's an example. In this code snippet, there is an expression with multiple operators. First, Python calculates the operation inside the parentheses, which is 8. Then, the exponentiation operation squares 4 and becomes 16. Following that, multiplication and division are executed based on their priority. Since they share the same priority, they're evaluated from left to right. Lastly, the subtraction operator is applied. So, the final answer for this expression is 15. When we run the code, we see the number 15 printed in the console, as expected. Understanding operator precedence is very important for writing correct and predictable Python code. It ensures your expressions are evaluated in the right order. We can combine these operators to solve many math problems, similar to writing formulas. However, for some more complex calculations, Python provides a better solution. In addition to the basic math operators, Python has a powerful math library containing many mathematical functions. These functions are part of the math module. The math module offers a wide range of functions for working with numbers, trigonometry, logarithms, exponentials, and more. Here are some of the most commonly used math module functions. Before we can use the math functions, we need to import the math module into our program. If you're unsure about how to use the import command and its purposes, don't worry. We'll cover the import command, how to use it in detail in the next video. Now that we have the math module imported, let's see these functions in action. We call each function one by one. These functions take one or more inputs, which we provide as arguments. We then print out the result of the function to display it on the console. To use these functions, first write the name of the math module, followed by a dot, then the name of the function you want. For example, print math dot fabs -2. The fabs function returns the absolute value of a number. This function is handy for turning negative numbers into positive ones. In this example, we give it -2 as the input. When we run the code, it displays 2 as the output. The ceil function rounds up the given number to the nearest whole number. In this example, we provide 5.3 as the input. The function rounds up 5.3 to 6. The floor function is the opposite of ceil. It rounds down the given number to the nearest whole number. In this example, we provide 4.8 as the input. The function rounds down 4.8 to 4. The pow function takes two numbers as input. It raises the first number to the power of the second number. In this example, we give it 2 and 3 as inputs. The function calculates 2 raised to the power of 3, which is 8. Pi and e are not functions. They're variables inside the math module that hold constant values. The log function gives us the natural logarithm of a number. In this example, we pass the value of the variable e as an input to the function and as anticipated, which gives us 1. Besides the natural logarithm, the math module offers more functions for computing logarithms. Trigonometric. Python offers trigonometric functions like sine, cosine, and tangent to work with angles. These functions take an input and return the corresponding value. Remember that they expect their input values in radians. So, if you have a value in degrees, Make sure to convert it to radians before using these functions. Converts the angle. These two functions are used to convert between radians and degrees. The radians function converts from degrees to radians, while the degrees function converts from radians to degrees. Once they are executed, the converted values are shown in the output. An example use case of the radians function is for working with trigonometric functions that expect inputs in radians. We've explored just a few common functions in Python's math module, but there's even more. This module provides a wide range of tools for various mathematical calculations. But for now, the operators and functions we've covered provide a solid foundation for working with numbers and performing calculations in Python.